time for your robot aided and additive manufacturing. So we would be working mostly with the RoboDK. It has only a 30-day evaluation copy, so make sure to maybe download it a bit later on. I've put it online in your software section, where I would like you to basically download this around January, so that you would have enough time to basically perform the project and still not have it in fully evaluation mode. Then what this software does is a very simple software. It's not that complicated. Initially, I am going to go into a bit detail about some other designs and some other aspects, but I thought that might, detract from what I'm trying to get to, which is how do you simulate this and what resources are available there for us to be able to perform that. But with the KUKA PRC, it probably would be the best option for us. However, it would be a bit more challenging to take this as an STL model and plug it in somewhere else. Here, I've just reduced it a bit. What you have to do for your part of your project is to be able to, let's say, slice it in particular more possible categories. Now, this particular parts, you basically go to that world section, and it takes you to a bunch of libraries there. Once you go to those libraries, you go and basically download a particular robots that you believe, with respect to its reach, can actually build what you're suggesting here and what you wanted to build from here. Then you could also play around with your reference frames, bring it closer to the robots, these types of things. You see, you can change there, you can bring it up, bring it back, left, right. These are the aspects that you can play around with and see which one is the best option for you. And then once we have that, so we can take it from there, then we can see how it is. After this, we have to also add an extruder. So the robot's arm cannot do anything. The robot arm is an arm that moves. It can either grasp something, it can either, let's say, drill something, but it needs some sort of tool on the top. So there are types of extruders that exist. So what this means is the technology, in order to be able to perform this, is not 100% out there. You have various different ones. You can do welding ones, all of these aspects. But let's say that we are doing an extruder with respect to that, with a traditional 3D printing method. And we're going to talk about this a bit as well. And then once you have that, you double click and it would basically attach it to that coordinates of that. You can play around with the coordinate system if you want. The software provides that opportunity, but then you can go to the 3D printing project, where if you have an STL, SAT, or whatever file that you've essentially saved your final result of your optimization of the shape there, what it does is it now goes to another software that is open source that actually gets to cut this mesh in proper sizes to be utilizable for any 3D printer. And this is typically for these 3D printers that you see. I have one in my lab as well. That is basically has a plane and then basically goes up and down and left and right. And once it gets one row, then it goes up a bit, and then it does another row, and then it goes up and then does another row as well. The KUKA can be programmed to perform the exact same way. So once it's the case, then it has the ability to now simulate what is supposed to happen here. And once it tries to simulate, and after a while it basically goes through, is essentially this, where you can basically update that, and then once you update it, you can also go and simulate what is happening there with respect to your robotic platform. And once you have the feasibility check that the software does, then you can go and see how it's simulated. So for instance, here, I have not provided any type of constraints. It could go inside of it. Really, if we're doing it outside, it cannot go inside of the structure, right? It has to go outside of it. that is what you see. It's going inside. If we're building something outside, it has to only be outside. So this is something that you have to keep in mind when you're performing the simulation. It has to have logical reasoning behind it. We're not building this in a factory. We're building this on site. So that is a part. But just for demonstration, I'm just showing you this. And then, for instance, this has taken about 12 hours. The whole thing typically depends on the speed, the amount of precision, and all of these items that exist. It could take anywhere from, let's say, 12, 13 hours to like 50 days. So we have to take that under consideration and be mindful about that as well. But those are the types of